for us to find the values of x, y, and z that correspond to the critical point of the function f of x comma y equals 5x squared minus 3x minus 3y plus 2y squared. To find a critical point, we first find the critical numbers, which are the x and y values where both first-order partial derivatives are equal to 0 or do not exist. So we need to begin by determining the first-order partial derivatives. Let's first find the partial of f with respect to x. To do this, we differentiate f of x comma y with respect to x, treating y as a constant. The derivative of 5x squared with respect to x is 10x, minus the derivative of 3x with respect to x, which is 3. And then we have minus the derivative of 3y with respect to x, which is 0, again because we're treating y as a constant, and then plus the derivative of 2y squared with respect to x, which is also 0, again because we treat y as a constant. And now let's find the partial of f with respect to y. So now we differentiate f of x comma y with respect to y, treating x as a constant. The derivative of 5x squared with respect to y is 0, again because we treat x as a constant, minus the derivative of 3x with respect to y, which is 0. And then we have the derivative of negative 3y with respect to y, which is negative 3, plus the derivative of 2y squared with respect to y, which is 4y. Now that we have both first-order partials, we set them both equal to 0 and solve as a system of equations. So we want to know the x and y values where 10x minus 3 is equal to 0 and where negative 3 plus 4y is equal to 0. Well, this system is pretty simple because the first equation only has x and the second equation only has y. So let's solve the first equation for x. The first step would be to add 3 to both sides, which gives us 10x equals 3. And then dividing both sides by 10, we have x equals 3/10. And then we solve the second equation for y. First step, add 3 to both sides, which gives us 4y equals 3. Dividing both sides by 4, we have y equals 3/4. So the critical point is when x is equal to 3/10 and y is equal to 3/4. To find the z-coordinate, we need to evaluate the function when x is 3/10 and y is 3/4. So now we need to find f of 3/10 comma 3/4, which is equal to 5 times the square of 3/10 minus 3 times 3/10. And then we have minus 3 times 3/4 plus 2 times the square of 3/4. For the sake of time, I've already evaluated this. It comes out to negative 63/40. Or as a terminating decimal, we have negative 1.575. I'm going to go ahead and use the fractional value of negative 63/40. So the critical point for the given function is the ordered triple 3/10, comma 3/4, comma negative 63/40, which means if the function does have a relative extrema, it would have to occur at this point. Before we go, let's look at this graphically. So here we have the graph of the surface, and the critical point is graphed in red. We can see the critical point does result in a low point on the graph, and therefore the point represents a relative minimum. In this case, actually, it's an absolute minimum. In the next part of the lesson, we will discuss methods on how to determine whether a critical point represents a relative maximum, relative minimum, or neither. I hope you found this helpful.